Evening, everyone, and welcome back to the Astro Imaging channel. This is David. I'm standing in for Adam this week a little bit. We're testing this out because he's going to be unavailable next week. Tonight, we're going to be doing a presentation on Are You Doing It? Talking about Arduinos and stuff like that. Nathan's going to do that for us. Before we get into that, though, let's go over our image of the week. Josh, you want to take that?
Thank you, David. So this is a nightscape that was shared on Facebook by Cody Sumter, and it was Santa Cruz. He took a handful of exposures of this lighthouse that was lit up with Christmas lights. You know, we'd love to have Cody come on next week if he wants to describe more about the image, but definitely a very unique image with the foreground kind of painted very prettily, and then very cool star trails here. So Cody, if you want to come on next week, we'd love to have you talk about it. For everybody else, if you want to submit your images for Image of the Week, you can submit them here. You can send us a message, or you can submit them on Facebook, where we have people put them in the comments there. So again, really nice picture there, Cody. Thank you.
Very nice. All right, Nathan, it's all yours.
All right, let me go ahead then and jump over here to the full screen. And do you see my presentation, the first slide?
We do.
Okay, perfect. All right. Well, good evening or good morning to wherever you may be at. Thanks for having me on here. My name is Nathan Woelfle, and my presentation is Are You Duinoing It? Arduinos, which are microcontrolled processors, and how we can actually use them in astronomy. I'm by no means an expert, just a proponent of the technology and the abilities of the controllers for simple application use. And I just kind of want to really share the simplicity of these controllers and how they can be integrated to help meet the needs. A little background about how I got into this. My lovely wife started the monster by getting me a scope a few years ago. And shortly after that, we had attended a local astronomy meeting. And at this meeting, one of the presenters had a short 15-minute demonstration or so about using an Arduino to control a camera rail for time-lapse photography with a DSLR. And I immediately saw the potential in this, in the controller, and I knew that I'd end up using them someday. So I started messing around with them in anticipation for building in an observatory, to which now I've already developed a few things here, and I'm currently testing them out, kind of, you know, working towards getting a final construction design built. So anyways, I'll jump right into the presentation here. So to start out with, obviously the presentation is focused on Arduino, but some people may ask, you know, why not include Raspberry Pi? And it is a good question. While Raspberry Pi is a great system, it's a little more complicated. There's truly real no right answer when it comes to deciding which to use. Depending on the type of project, there may be reasoning to favor one over the other, or even sometimes implementing both. The specification differences between the two also renders direct comparison somewhat moot on paper, especially considering the Arduino's 16 megahertz processor falls short of the Pi's 900 megahertz chip. The fact is that the two devices have different uses and advantages, each of which is achieved through different methods. So I just wanted to spend a little time just talking about the differences between the two popular options for personal development or control, and discuss why Arduino is a good choice for the base projects. So for all intents and purposes, a Raspberry Pi is a fully functioning computer with a dedicated processor, memory, and a graphics driver for output through HDMI. It even runs a specifically designed version of the Linux operating system that makes it easy to install most Linux software, unless you use the Pi as a functioning media streamer or even a video game emulator with a bit of effort. The Pi doesn't offer internal storage. You can use an SD card as the flash memory for the entire system. This allows you to quickly swap out different versions of the operating system or software updates to debug. Because of the device's independent network connectivity, you can also use it to access via SSH or transfer files to it using an FTP system. Arduino boards are microcontrollers. They're not full computers. They don't run a full operating system, but simply execute written code as their firmware interprets it. You lose access to the basic tools of an operating system provides, but on the other hand, directly executing simple code is easier and is accomplished with no system operating overhead. The main purpose of the Arduino board is to interface with sensors and devices. So it's great for hardware projects in which you simply want things to respond to various sensor readings and manual input. That may not seem like a lot, but it's an actually very sophisticated system that allows you to better manage your devices. It's great for interfacing with other devices and actuators, whereas a full operating system would be overkill for handling simple read and response type actions. The two systems have different power requirements. When it comes to providing power, the big thing to keep in mind is reliability of the power supply. The Raspberry Pi requires a constant 5-volt power to stay on. Arduino, on the other hand, can use between 7 and 12 volts. This may seem trivial, but it's important when it comes to the device's reliability and potential lifespan. It's even more important when it comes to portability, as this can be an issue with the Pi. When the Pi is on, you must activate the programs unless you have them auto start, kind of like with a computer. But the Arduinos begin executing code when turned on and simply stop when you pull the plug. The Pi, as being a computer, should be shut down via a software process like a traditional computer to prevent corruption. So even if the power drops on an Arduino, you won't end up with a corrupt operating system or other software issues. It will just run the code when it gets plugged back in. The Pi does offer built-in Ethernet port. It does allow easy access to any network with a little setup. Wireless internet also isn't hard to achieve either. You just have to either buy a USB Wi-Fi dongle, or you just need to go. You can get the new Raspberry Pi 3. That one actually has the Wi-Fi chip built into it. Once you're connected, you use the operating system to access web servers, process HTML, or post to the internet. You could even use it as a VPN or a print server. Unfortunately, though, most Arduinos aren't built for network connectivity directly out of the box. It does require a bit more tinkering to set up a proper connection, though it is possible. You need to get an extra chip outfitted with an Ethernet port, and you'll need to do some wiring and coding in order to get everything up and running. While the Pi and the Arduino have a number of interface ports, it's easier to connect analog sensors to the Arduino. The microcontroller can easily interpret and respond to a wide range of sensor data using the code you put on it, which makes it great if you intend to repeat a series of commands or respond to sensor data as a means of making an adjustment to servos and other devices. The Pi, on the other hand, requires software to effectively interface with these sorts of devices, which isn't always what you need if you're trying to just water plants or keep your beer at the right temperature. It would be good, though, when you otherwise want to complete tasks with a personal computer. The Pi also makes a slew of operations easier to manage, whether you intend to connect to the internet to read and write data, view media of any kind, or connect to an external display. For example, the Pi is a much more appropriate type of system to use if you're wanting to create an all-sky camera. Because of its processing speed and video support, it makes handling this task much easier. However, it's not uncommon to end up actually using both in a project. So with the Arduino acting as a control board that executes commands issued by the Pi software even before the sensor information is fed back for recording or responding to. So, just to kind of go over the slide here a little bit, as you see, the Raspberry Pis are going to cost you about $35 US. Arduinos, depending on when you or where you purchase and the version, they can range anywhere from $1 if you get them off eBay, all the way up to $50 for the larger Arduinos. But obviously, in this case here, the Arduino Uno would run you about $25 if you buy, a genuine one from Arduino. What also makes this a little hard to go through is some of the Arduinos do support Bluetooth or have that built in. There is even currently a new Arduino out that if you see where the IDE is, it just shows Arduino. There actually is a new Arduino that actually does support Linux as well. So again, direct comparison makes it a little moot on point. But by now, I bet you're obviously probably asking yourself, so which one's right for me, or when should I choose an Arduino? And the answer depends. Again, it really depends on your project, but obviously the focus tonight is going to be Arduino. So with the Arduino, it's a great device for when the main task is just reading sensor data and changing values on motors or other devices. And given the low power requirements and upkeep, it's also a good choice if your device is going to be constantly running and requires little to no interaction. Another way to decide which may be best and more simply explained is to think about what you want your project to do. A general rule to follow is if you can describe it with less than 2 ands, get an Arduino. If you need more than 2 ands, probably a Raspberry Pi. So for example, I want to monitor the roof position and have it open or close the roof. That can probably best be done by an Arduino. Otherwise, if I want to monitor the roof position and have it open or close the roof and check the National Weather Service, and if the forecast is for fair weather, open the roof. Otherwise, if it's going to rain, do nothing or close the roof. That would probably be best handled by the Raspberry Pi. Are there any questions yet? All
There
right.
have been a couple comments here. I think you covered one already about the price of Pis. John Eric Minerva also says that there's a nano version.
Yes.
And then we have an unrelated question that I was answering about PhD.
All right, perfect. All right, well, then I'll dive right into the world of Arduino. So what is Arduino? Arduino is an open source project that creates microcontroller-based kits for building digital devices and interactive objects that can sense and control physical devices. Arduinos use inputs and outputs in the same way as an ordinary computer. The inputs capture information from a user or the environment, while the outputs do something with the information that has been captured. An input can be digital or analog and could come from the environment or a user. Outputs can control and turn on and off devices such as motors and other computers. In these systems, they're provided a set of digital and analog input-output pins that can interface with various circuits and expansion boards, which are termed shields. We'll get into that a little bit more here shortly. In addition, the boards feature serial communication interfaces, also including USB on some models for loading programs, monitoring, or interaction. To program the microcontrollers, the Arduino project uses an integrated development environment based on the programming language named processing, which is also supported or similar to that of C and C++. The Arduino language, being similar to the C, is great, and there is a nice benefit that there is also several libraries that are provided that allow for easy use, as well as integration of other devices like thermometers or anything that you want to use as well in there. And as was already mentioned in there during the question to Nano, the Arduinos come in a variety of different boards. The boards are commercially available in pre-assembled form or as even do-it-yourself kits. Because Arduino is an open source project, the hardware design specifications are openly available, allowing for the Arduino boards to be produced by anyone. So I'll move into actually talking about the different types of Arduino boards that are available. So with the many different types, there's currently about 17 official ones. And most of the comparable differences are going to come down to about dimensions, the amount of analog or digital pins, the CPU speed, operating voltage, and memory. I won't go into the details about all of the differences in each board, but instead just focus on a few of the designs here. So starting with the Arduino Uno, this is one of the most popular boards, not only because it is included with most of the kits, but it's also about the same size as most of the compatible shields, which allow for easy stacking. The bottom picture is of the Nano, which is similar in capability. The biggest difference, obviously, is going to be size, but there is also one that's called the Micro, or the which the new one is now even called the Zero. Another neat feature kind of across the board, but worth mentioning about all of them, is the built-in pulse width modulation. This is great when you need to control LEDs for a light box or potentially a Do controller. So as you see on the pictures here, very similar, you have your USB port. They can run off just USB power. Otherwise, if you do need more than just the 5 volts, they do have, at least on the Uno, they do have a separate power spot for the power supply. And then you do have your 14 digital pins, and then you have your analog pins, and then your power rail. And then the Nano is very similar. It's just obviously a lot smaller design, but again, same thing. You have your digital pins, and then you have your analog pins and your little power rail. And they also do have a reset button in case you did need to go ahead and reset them. Besides the Uno or the Nano, the Mega is also a very popular choice due to having the number maximum of input-output pins as well as more memory. Compared to the Uno, which has 14 digital pins, Mega contains 54, 8 more of which are also available for the pulse width modulation use. And it contains 16 analog pins compared to the Uno's 6. So again, same thing. It has all the digital pins across the top, but just for board space, the digital pins also go along the back. And then you've got your analog pins as well as in your power rail, still with USB, and then a power spot as well. And then one more design to kind of look at. This is a notable design. It's called the Yun, or Yun, however you want to say it. It is a newer, unique product, and unlike the past Arduinos, Yun is the exception to the typical Arduino style because it incorporates some of the features of the shields that we'll talk about in a minute. But specifically, this has the Ethernet and SD card built into the actual Arduino. But that's really about the biggest difference in the board design. What is also unique with this one as well is that it also does provide, or the ability to support, power over Ethernet as well. So really, when it comes down between these main boards, when deciding on which one to use in the past, it came down to the amount of pins that you needed for all your sensors and controls, as well as the memory for holding the necessary code. However, one major thing to look at now when comparing which one to get is the operating voltage. This is different from the input voltage that I mentioned earlier. In the past, all of them operated at 5 volts, but now there are choices that include 3.3 volts. This is important when it comes to adding sensors and other controls, but it's beneficial because it aligns with the Raspberry Pi. So this provides more opportunities for the sensors to be used with any system, which makes it obviously cross-compatible and allows for easy reuse when developing or upgrading your system for the integration. Are there any questions yet kind of about the devices?
Yeah, so we got, well, not necessarily about the devices. We do have a few questions that have come in.
Okay.
So let's see. Someone asked if there's an ASCOM library. I think there was an answer partially already, but go ahead and see if you can answer that one.
There is. Because of that serial interface, it does support ASCOM, and I'll kind of touch on that here in a little bit as well.
Okay. Let's see. Someone was mentioning about the Arduino is programmed in C++, not its own language.
From what I understand, it is its own language. I mean, that was taken from Arduino's library, so to speak, from their history on it. So maybe that's outdated now at this point.
Is that a nomenclature thing of API versus the language it's programmed in, maybe?
It could be. I'm not sure on that.
Yeah. Okay. Let's see. Next question. Jared is saying that if you're contemplating a Yun, you might also consider the Pi plus Allo mode. I don't know if you cover Allo mode in your presentation here.
I did not cover that one. There really are so many different types of boards. There is even a new Arduino Uno that actually also does have the Ethernet port and an SD card built into that one as well now. I'm not sure though if that one supports the power over Ethernet. So that's what I'm saying. There are like 17 different versions, and that's the genuine versions as well. Just because of that open development or open platform, I mean, these can really be customized or built however anybody would like them to be.
Okay, I think that's it so far.
Okay, then we'll move on to actually talking a little bit about the shields. So the shields, as I hinted about earlier, these are board designs that can be stacked onto an Arduino to provide more capabilities. There are currently about 13 official shields that provide these additional support to some features. To name a few, this could be an Ethernet, GSM, or Wi-Fi shield to provide connectivity through either an internet or cellular connection. There's a motor shield for integrating with motors. There's also what they call a proto shield, which is the one actually in the bottom right-hand corner. It's just a PCB that allows for the circuitry to be soldered directly to it. And just like the open development of Arduinos, the shields can be built by anyone and include any number of features. Really about the only thing that's going to potentially limit you is the amount of memory that would be necessary to code the board and still have room for your project. So with these shields, I'll actually just kind of jump right into actually the whole point of this presentation, which is how they can actually be used in astronomy. So, talking about the capabilities of Arduinos with the possibility of expansion if necessary with the shields, they do seem to have some great abilities, but obviously some people are probably going to ask, so what can I really do with them? Some of the implementations that I've seen include controllers built to control a roll-off roof, dew control system, focuser, filter wheel, telescope go-to, barn door tracker, weather station. I mean, the possibilities are rather endless, and that's what really makes it nice. Is it's not only their low cost, but the ability to create something that specifically fits your need, or even being able to find a design that's already been used out there and being able to critique it, to support what you're looking for, or even just being able to implement the design that someone else has already spent the time, having to figure out how things go together and properly work. And then back to the original question that was presented about ASCOM. That's a great benefit to the Arduinos with their ability to support ASCOM. Because that serial interface, you are able to develop drivers and software that do provide control of an Arduino. Depending on the project, there is some ASCOM support that has already been widely developed and available. However, I have not really seen a lot of open development on the subject. But with ASCOM, there are templates available. You can go to ASCOM's website, download the templates, and pretty much just plug and play the information that you need to actually make it work for your system. So all these templates, as well as the software, can be altered, helping just reduce the amount of time spent for development, or for those who don't have a programming background. So with these possibilities, I kind of wanted to it is about astronomy here, but I did kind of want to talk a little bit about how to actually program one. The programs that are developed, they're actually called sketches. Regardless if you have programming experience or not, there is already a large database of already designed sketches, as well as many tutorials to really help you create your project. The Arduino website itself has a complete forum with discussion as well as sketches, but they can really just be found online by doing a search. And for the most part, again, you're able to simply copy and paste the code into the interface. And again, with all these, they can all be altered, combined, separated, allowing you to kind of really develop whatever it is you need and reduce your time spent programming and not reinventing the wheel every time. So if you look at this example here, this is really simple. It's just a blink the LED. So there are two parts to a sketch. There's the setup and the loop. The setup is where you define the parts of the system. So in this case, pin mode is where we define that pin 13 is an output. So the information will be sent through this pin rather than received. The second part is the loop. This is where you actually write your code for what you want the controller to do. In this case, digital write means we're sending information, and then in the parentheses, the 13 is the number that we're sending the information to, and then high means that power is being applied. At this time, the LED light would come on. The next line of code is delay, which means that nothing happens. No code is actually executed at all. The 1000 in the parentheses is the time to wait in milliseconds. We then move on to the next line, which is the digital write again. So we're sending information again to pin 13, but low, which means that no power is going to be applied. So the LED would then be off at this point, and then again the system delays for a second. So as we talked about earlier, as long as the power is applied to the Arduino, it would constantly run, and again, it requires little to no interaction. So in this case, the loop would do just that. It would continue to process the code over and over until the plug gets pulled. So the LED would turn on for a second, and then off for a second, and repeat that way until the power is removed from the board. So once you've designed your sketch, you do one of two things. You can click on the check mark over here in the top left. If you click this check mark, this will verify your program and highlight any areas where the logic is not properly managed. What it'll do is allow you to then go back and change anything in the code that is not correct. If no errors are returned, then you can click on the button next to it, which is the right arrow. This will upload your sketch to the Arduino and then start running. You could bypass the check mark because when you go to upload your code, before your sketch is uploaded, it also verifies. And if errors are present, it actually won't upload the sketch, but instead time out and highlight, and then in the black bar across the bottom, it would display something about what the error is telling you about. So, and as we were talking about, you can buy these as cheap as $1 for a nano off of eBay, all the way up to the mega, which runs you about $50 for a genuine one. So, one of the greatest things about the Arduinos is their low cost and their durability. So, let's say, for instance, that you wrote your sketch and uploaded it because no errors were discovered, but it doesn't seem to function like you expected. You don't have to worry about, hopefully, anything breaking or anything. All you'd have to do is go back, redo your code, and then upload again. Nothing, hopefully, would be ruined. But similarly, if you want to repurpose or redesign your project, you can reuse the Arduinos. All you'd have to do is create the new sketch and upload it, and it will overwrite the existing information. So again, the possibilities are really endless for an Arduino, and it can be used to either test out your idea or be used as a finished product. Are there any questions yet or more?
There's definitely some other questions here. Let's see. So Tolga asked, can you install the same code from one model to another?
Yes, as long as it's still supported. Obviously, like if you use the Arduino that has the Linux version, obviously no. But otherwise, like from an Uno to a Nano, yes, you could. The only limiting factor that would otherwise be into play is going to be the memory. Something like the Mega has 256 kilobits of memory, so it has a lot more space to be able to put it. So obviously, something from the Mega may not necessarily go back to the Uno, but as long as it fit within that memory space, yes.
Okay. When you use shields, do you lose any input or output pins?
Good question. You definitely do. Because those shields are stacked on top of each other, they do require certain pins. Some of them, again, are predefined. So for instance, like the Ethernet, if I recall correctly, automatically uses pins 10 through 14. So those are out of the ballpark to be able to use. I also think it uses pin 4, if I recall correctly as well. So you do lose some of those pins for it, and that's where with those shields, something like a Mega may also be a better addition or a better platform to build off rather than an Uno. It won't necessarily fit the whole design, the whole board, or cover the whole thing. But again, you can code the information necessary to run the shield, but then you'll still have enough room to then code your actual remainder of your project that you're needing.
All right. James is asking, and I'm not sure if this is directed at you or part of the chat, have you had any luck with NextDome's GNU code or anyone else's code for observatory control? That may have been directed at Jared.
Okay, yeah, I'm not messing with those.
All right. Let's see. It's quite a few to wade through, but not all of them are related to
Sure.
the topic here.
All right. Well, then I'll go ahead and move forward here a little bit. So, like Arduinos, I love money. So I wanted to go kind of over the practical use and the financial impact to how this can definitely be a great choice for some people. So as we've all come to learn, our choices for astronomy-related products isn't always vast, but for the most part, it's at least not non-existent. So when building something from scratch, there's always going to be some unknowns, but as people have mentioned in the past, by learning how all the parts function, you learn the ins and outs of how the product works and how to diagnose any issue or potentially improve upon a design. However, there are those that would rather just buy a product rather than build something, and there's absolutely nothing wrong with that. There could be a multitude of reasons why one would want to do such. Simply something as being they want to buy and support a reputable dealer, or people's testimonies for a known reliability in a product, or they just don't have the tools necessary to create certain parts, or they're under time constraint. They need to get a product in a short time that's most likely plug and play. But what's really great with the Arduino system is that there's that learning process as well, and then the financial benefit to building something yourself. This one here is actually a focus controller. This is actually a project that I helped my observatory buddy with make for his scope. So as you can see, it's just on a simple board. This is actually utilizing an Arduino Nano. And then the other little board to the side is a driver board for the stepper motor. So as you can see, it really only requires a handful of parts, yet this simple, reliable focus design has the full ASCOM support, and look, just the pieces together, not obviously, including the brackets or stuff, but various pieces, you can easily build a full stepper motor controller for under $50. You could, even if you wanted to, this is something that you could alter the design to incorporate a thermometer for temperature monitoring. So that way, then it could be integrated in with the ASCOM support. So that way, if certain temperatures are detected, you can go ahead and have a new autofocus routine run through any system. And obviously the prices are going to somewhat vary. Like I said, a Nano, $5 for pretty much a genuine one. You can find them, or semi-genuine. You could buy them off eBay for $1. So it's not a huge risk to buy a couple of them if one breaks, or it just doesn't work. You just plug in the next one and go with it. Are there any questions yet?
Looks like there's a lot of chit chat here. I'm not seeing any specific questions. There's some comments about there are tiny modules to handle temperature, humidity, pressure, right? Which I think you talked about a little bit. But for something like a sensor, a heater, right? You'd want a relay, and I think Jeff said there's a module for that. I'm not sure if you've used anything like that before.
I mean, I've got a few different projects, and I'll kind of go into those here in a little bit. I mean, the biggest thing you have to really worry about with any of these boards is blowing them up, just putting too much power into them. And so that's where some of these things are very nice. Like in this one here, we've got the board, the Nano, and then you've got the driver board. So that way you're able to, like in this case, there is a 12-volt power supply that is going to this, but it is not going to the Nano. It's only going to the driver board. So you do create somewhat of an isolation in some of the parts. Even for something as simple as the Nano, I didn't talk about it, but back to those shields, there are even shields that are designed for the Nanos. So you don't have to worry about having just the big boards as well for use.
That's it so far.
Okay, excellent. Then I'll kind of go into some of my projects here that kind of go over it. So far, I've actually created 3 Arduino projects. I've so far got a focuser, a do controller, and a roof control. Robert Brown is actually kind of the one who kind of got me started or got me steered in the right direction. If you just Google Robert Brown, he's actually got a SourceForge page with all of full documentation for all of his projects. He's actually gone ahead and done multiple versions of the Arduino project with both stepper motors as well as DC motors. So there's lots of variations of his products that you can utilize for the focuser and for the do controller system. He's got a lot of versions. So that way, if you want something strictly that is fully automated, like you literally just again, plug it in, power's applied, the Arduino would kick in and start monitoring power. He's also got it to where you can go ahead and have a user interface, which is kind of more of what I've got, and I'll kind of go into here in a little bit. But this setup here is actually my focuser and do controller. So as you see, one Arduino is actually controlling just the focuser. The other one is the do control system. I went ahead and built it all into one box because what I did was I mounted this on top of my scope. This is actually mounted to a dove plate. I 3D printed a box here. There's actually a box that runs underneath between the two. What I've done here is I took actually a 10-port USB hub and mounted that one in here, and I went ahead and sealed it up just for the purpose of being able to make sure that no dew or moisture gets any of the contacts and shorts it out or corrodes them after time. So what I did was I actually took that USB hub and ran the wires through the underside of this dovetail plate. And then over on this side here, I had them come out the side to hopefully cut down on moisture. And then as we're talking about those sensors, this actually is the white part is a temperature and humidity sensor for the do control system. And then you've got actually the 2 RCA jacks for any do straps. And then the bottom part is actually for the thermostats or the thermometers. And this is actually just a close-up view of the connection point. So the RCA jack, and then the thermometer. And again, I 3D printed a cell that holds it right up against the actual optic up on the front. And then with the next part here, this shows kind of everything all combined here. So this is great, again, with the Arduinos, able to create these full systems, and I was able to mount it on top of the scope. So this really cuts down on the amount of wiring that's going off the scope utilizing the Paramount series. I literally have just everything going down to my Versa plate, and then there's just a couple of cables that go through the mount and then out the bottom. But this allows everything to be really nicely managed and tucked away together. with showing that the do control system. So this one is an ASCOM. The focuser that I have on here, again, Robert did a great job providing the ASCOM drivers that you need. So that way you've got full support for it. But this is the do control system. I opted to actually utilize the computer because, again, I'm an observatory. I don't need to actually be out on site somewhere. But he does have the do control system to where you could even integrate an LCD screen into the Arduino and have those connections there with push buttons to allow you to toggle through the screens. But this is the interface for the do control system that shows, obviously the relative temperature and the humidity, the current optics of the scope, as well as the dew point. You can then go through here and actually change how you want it to track. So you can have it keep the optics or the channel 1 temperature at ambient. You can have it be at the dew point or somewhere in that middle. You can also incorporate a fan, which I did just to help kind of cool down the electronics during the summer. And again, you can change the speed there as well as the refresh rate. And the refresh rate is for the graph on the side here. This is where you can go ahead and actually have it log all of the details throughout the night. So you can choose, 30-second refresh rate or 5 minutes. And this will go ahead and again, just track it and allow you to then pull it up the next day if you need to, as well as it also provides the ability to individually turn on either one of the dew straps if you just need a little bit of extra power. And what's great is that it'll automatically shut off after about 2 minutes, so you don't have to worry about it being on too long and using a lot of power, or not being off for too long. The last project that I actually created is the roof control. So this actually here shows the Arduino Uno, and this is actually one of the actual pre-manufactured shields, which as you see is stacked on here. This is the Ethernet one. And this allows me, what I was able to do is provide a user interface through a website. So that way I can log in and see what the current status is of the roof, whether it's open or closed, as well as then being able to activate the roof. Or as my friend Sean, with being in the observatory with me as well, in case I decide to open the roof, there's also a spot on here that it has a speaker actually I've built into it. So it warns him for about 5 seconds saying, open the roof, it's opening, better get off the roof. But this is just a simple layout here for you. So as you see, I built my own shield that then plugs into the Ethernet shield. So this provides the buttons. So if Sean wanted to actually push or activate the roof inside, he can just push the button. And then it's got the connection points for the sensors to tell me tell us whether the roof is open or closed. And then obviously for the relay. And then this is that interface as well. So ultimately, as you see on here, it shows that the roof is closed. One other nice thing and this is not coded into the Arduino, but what you actually do is with that Ethernet shield, because it also has an SD card slot, you're actually able to write code on that SD card slot and reference the Arduino to that code to then, in this case, show a website. So this is a little bit kind of off topic there, but you're able to then also, as I see on here, there's roof locked. There's actually a check mark box there. So if for some reason, Sean is trying to do something to the roof, straighten it out or mess with something, he can actually lock the roof. And so that way then if I were to try to activate the roof, a warning comes up saying you can't do anything. So you need to first off go ahead and undo the roof, have him uncheck the roof, or even I could uncheck it. And then once that's done, then the roof would activate, and then it opens and closes and shows you the current conditions. And this is that one project where, as I mentioned, this is currently in Arduino development, but I'm working actually towards moving this one towards to the Raspberry Pi. I'm in the process of developing a full weather station, as well as rain sensors and all sky camera, and all of that's going to be able to be combined and put onto that one Raspberry Pi to have access for all that system as well. So that's really what I've got for the Arduino system. It's very simple. Really the the biggest difference is, or the biggest thing that's going to come into play besides the Arduinos is obviously having that knowledge or ability or to do some soldering potentially, maybe something necessary. You could potentially just plug in the sensors directly into the top. And that's one thing I didn't really get into, was the sensors. Just like the Arduinos, there are so many different sensors. I mean, there's a plethora of whatever you want to put out there that can almost be integrated with it. So, I mean, it's really an endless possibility for the simplicity of an Arduino system.
All right, let's see. I think we have a couple more comments more than questions here. Jeff was saying that the hardest part of his Focuser project was the 3D modeling the bracket and printing it 10 times to get the right size. Did you find something similar with yours?
For printing the brackets, no, that part I did not. There's already a lot of technical documents on there that, you know, just on the internet. So like for the stepper motor, there's the technical documents that you know, give you the size holes that you need for everything and the dimensions of all that, of all the placement for, you know, the holes and size of stuff. And then I've got a Moonlight Focuser, and so ultimately I already had some spacers, and so really it was just a matter of reverse engineering it and kind of making a complete system. The only thing that I can say that definitely did take me a little bit, yeah, and it goes back to that you know, the development phase of the unknowns. The big parts that took me a little bit of time to get straightened out was actually building the Do Focuser controller system all on that dovetail. Trying to get everything aligned up properly within all the points there. That took a little bit of trial and error. Printing out, like in the Arduino or in the Do control on the side of all the electronics where the Do or where the two Arduinos are, there also is, which isn't in the picture, there's a small little 10mm fan that's in there. So that took a little bit of figuring out how to get the placement just right with all the other electronics, and then figuring out just kind of how to print it. I'm not going to say it was, you know, first time was done. I probably did the Focuser, the spacer one, that took me probably about 3 prints to design, and then the Do controller one, probably I'd say about the same thing, 3 or 4 times trying to make sure I got it, you know, just right. And that's where, you know, that system is actually temporary. I'm actually going to combine all of that into an integrated dovetail. Is actually what I'm looking forward to doing. Again, this is just the beginning phase, hopefully, of a lot of those products.
Excellent. I'm not seeing any other questions specifically related to the presentation here.
Okay.
So thank you very much, Nathan. Now's your chance, guys. If you have any other questions for him, definitely ask them. I think just a couple more comments in talking about Fusion 360 for 3D printing files. Yeah, nothing related to you.
I mean, one thing you could even do for some people, you can actually use an Arduino to make a 3D printer. So, you know, the possibilities are completely endless when it really does come to the Arduinos. You know, one thing I didn't touch on as well is that you can use multiple Arduinos and they can interface with each other. So it is not necessary it isn't a requirement that you only use one Arduino. If you sometimes need to, like, again, just like even combining a Raspberry Pi and an Arduino, sometimes 2 or 3 may be necessary. It depends on the projects. You know, non-astronomy related, I've seen there's almost people making their own virtual reality goggles now. I mean, if you just check out Arduino's website, even there, I mean, there's thousands of projects and millions of them that people are, you know, using these things for everything.
Did you have any links or preferences to sites you usually go to for projects and stuff like that?
No, I really do all of my own development. Like I said, the only thing that I utilized was Robert Brown for his Do controller and the Focuser. I believe all you would have to literally do is just Google search Robert Brown Focuser, and that'll bring you right to his SourceForce page. You can then click on it, and like I said, he's got documentation where he's got the original version. He's redeveloped it and made a second version. And then he's really done a very good job as far as breaking down. If you wanted to design it this way, utilize these folders and help files, or if you want to do it this way, do it that way. But no, like especially that roll-off roof one there, that's something I've just designed on my own. So really, it's just I would recommend the Arduino website. It's Arduino, Arduino.cc. And Arduino.cc, that is Arduino's website. There are, if somebody is interested in purchasing them, like I said, I really don't find any reason why not, why you need to necessarily buy the factory ones. They're called, there is Arduino and there's Genuino. I guess the Genuino is the generic or the official version, but I believe that's more in Europe. But really just Google searching Arduino. And even when I first kind of got started with the Arduinos, just to kind of get my bearings straight, the Arduino for Dummies is a great book as well.
Excellent. A couple other people mentioned Adafruit and SparkFun. It sounded like Adafruit had a shield lookup that might be useful for some things.
Adafruit is one of the more popular electronics websites to be able to purchase a lot of any product, whether it's Arduinos, Raspberry Pis. They also have a wide array of just parts in general. So whether you're needing to buy capacitors or resistors, anything like that, or the sensors. I mean, they have a huch array. SparkFun, I've not messed with their site. Another one that I've used is SwitchDoc. It's SWITCHDOC. They've got a few products. That's more of a weather station type place, but they do have a few different products as well as build material. Even another good website that some people may enjoy is Instructables. They have a good breakdown for some people as well as some of the projects. Some are pretty detailed, but some could also be kind of vague.
Do you use anything in particular for doing the programming?
As far as programming the board?
Well, I mean, like you using Visual Studio. What are you using to do the coding in?
So there are two ways. I've really only utilized the standard way, which is Arduino's development, their own user interface to go ahead and program it. There is also through Visual Basic, there is a plugin that you can download that allows you to go ahead and actually through Visual Basic go ahead and write the code and then send it to the Arduino utilizing the serial port.
Okay, it sounds like Jared's also using Visual Micro through Visual Studio. Not sure
that might be the name of it.
Yeah. Okay, and let's see. Do you use any data logging websites for your Arduino projects like Grow Streams?
Nothing that I have created so far has really needed any type of logging. The only thing that obviously I've got so far that does the logging is the Do controller, but honestly, I don't really even actually utilize the logging part of it. For the other project where I'm actually creating the full weather station, all sky cam, roof control system, that side there actually, I am able to go ahead and have everything with that Raspberry Pi. Like I said, it's really a miniature computer. So I've actually gone ahead and downloaded XAMPP on that and got my own setup there to go ahead and log all the information. And that way then I can go back in and review any of the information or use it for some processes.
All right, that's all the questions I've seen.
Okay.
Well, thank you very much, Nathan. It's an excellent presentation. We appreciate you doing it.
Thanks for having me on. I appreciate it.
All right, guys. We'll talk to you later.